Hi everyone. Today we're going to be talking about equations of lines. This is it. We finally got to linear equations. This is going to be tough stuff, so stay with me. First thing I wanted to do was start out by giving some vocabulary. We should have already heard it before, but we're just going to review it. So we already know about slope. We saw that in the last video. And we know that slope is the ratio of rise to run. We're going to see its use today. We also have heard the word y-intercept, and we know that the y-intercept is the point at which the graph crosses the y-axis. The other thing that's going to be really important today are the formulas that we're working with. So we have two types of formulas with our linear equations. The first one is standard form, and we see that that's ax plus by equals c. The second one is slope-intercept form, which is y equals mx plus b, where x and y are variables, and the slope is m, and the y-intercept is b, or 0b as a coordinate. And the third formula that we're going to need is going to be our slope formula. Again, we saw this during our slope video, so it shouldn't be unfamiliar to us. So let's begin. So the first thing we want to do is be able to identify the slope and y-intercept within a linear equation. Again, going back to our formulas, we know we're going to be looking at things either in slope-intercept form, y equals mx plus b, or standard form, ax plus by equals c. We love slope-intercept form because that tells us the two things that we always want to know when we're working with linear equations. The slope, m, and the y-intercept, b. So look closely where the slope belongs. The slope is the coefficient in front of the x. So if we can find that x variable, we know the slope is going to be directly in front of that. So now, let's look at our examples. On example 1, it's asking us again to find the slope and y-intercept. So if we look, we have to remember that form y equals mx plus b. Again, where m is our slope and b is our y-intercept. So looking at our first equation, we have y equals negative 3/2 x minus 6. Hopefully, again, we identify where our x is, and we know that in front of that is going to be our slope. So our slope here on number 1 is going to be negative 3/2, and our y-intercept is going to be the other variable that we're given. In our case, just like when we're solving equations, we take that sign in front, so we know our y-intercept, b, is going to be a negative 6. Don't let the next couple throw you for a loop. On number 2, to identify our slope, again, we see our x, so our coefficient is 5, so that's our slope. So the y-intercept is going to be, well, since we don't see one, we assume that it's going to be 0. Again, in the first one we actually saw the negative 6. Since we don't see one now, we assume that it's going to be 0, and it is. Okay. Let's look at number 3. So on number 3, there's a trick to it. Again, we have to remember that anytime we are trying to find the slope and y-intercept, the slope is the coefficient, that number in front of the x. Well, if we look, first of all, hopefully we notice that our slope and y-intercept have been switched around. Don't let that fool you. Always be careful of that. The second thing is when we look at our slope, we notice we don't actually see a number in front of this. This goes back to when we were first learning how to simplify expressions. Whenever we don't see a coefficient, we know it's going to have a coefficient of 1. So our slope here is 1, and our y-intercept is 10. How many of you thought it was the other way around? Okay, so let's look at number 4. Uh-oh, fractions. So we're going to see a lot of fractions as we work through linear equations. Don't let that bother you. So the first thing we notice here, again, they're playing a little trick on us with the writing here. We notice that our x is actually the second term, not the first term. If we look, though, our slope, hopefully we're able to identify, is 2/3, and our y-intercept is negative 8/3. Again, don't let the fact that it's a fraction bother you. Just focus on identifying slope and y-intercept. So 5 and 6. These two are by far the worst out of all 6 of these examples. The reason why? Because they're no longer in slope-intercept form. We can identify the slope and y-intercept. They're all in standard form. So there's a couple ways that we can solve this problem. But I feel like the easiest thing is to actually convert both of these into slope-intercept form from standard form. So how do we do that? Remember, slope-intercept form, when we look at that, has the y by itself. This is going to require some math. So if we want to get this y by itself, the first thing we have to do, as we're solving equations, is move that 3x. So I'm going to move the 3x by subtracting on both sides. It's gone on the left side, so we're only left with 4y equals. And on the right side, since these two are not like terms, I just want to rewrite it. Because our slope formula had the x term first, that's why I want to put it first. So negative 3x plus 15. Again, when we look back at our slope-intercept form of an equation, the y has no coefficient, or its coefficient is 1. So I need to get rid of that 4. So how do I do that? Well, hopefully we remember in solving equations that we have to divide. So I'm going to divide everything by 4. Now don't freak out because these are fractions. That's totally fine. Again, look at example 4. So I'm going to get rid of my 4's here. The only thing that's left on that left side is going to be y. Now, we don't have to do a whole lot of stuff here. We don't have to convert to decimals unless we want to. We don't have to make anything a mixed number. All I need to do is just write this as a fraction. So negative 3/4 x plus 15/4. Because we did say that word fraction, we do want to make sure that everything is simplified. There's no more that I can simplify with the 3 and the 4, and 15 and 4 also have nothing in common, so there's nothing I can do to simplify that. So this is going to be our slope-intercept form, converted from standard form, of the equation. So now we get to finally answer the question, which is what's the slope and y-intercept. Now that we have it in a form that we can recognize each of those pieces pretty easily, hopefully we can see that our slope is going to be negative 3/4 and our y-intercept is going to be 15/4. Again, don't get worried about the fact that it's a fraction. Fractions exist. That's what we work with. All right, and our last example is number 6. Same thing here. Again, we notice that we're in standard form and not in slope-intercept form. Slope-intercept form, when we look at this earlier, we know we have to have the y by itself. So that's the first thing I'm going to do. I need this negative 5y to be by itself. So I have to move that negative 7x. So how do I move that? I add 7x to both sides. I'm going to get rid of my 7x's, so I'm left with negative 5y equal to 7x plus 22. Again, we can't combine those because one has an x and one doesn't. They're not like terms. And again, because we need the y completely by itself, we can't have a coefficient, so I'm going to divide everything by negative 5. The negatives are gone, the 5's are gone, so the only thing that's on the left side is going to be y equals, and since I can't simplify this, I'm just going to rewrite this as a fraction, negative 7/5 plus either negative 22 over 5, or if we wanted to just see that we have a negative sign there, the other way I can write this is negative 7 over 5x minus 22 over 5. And again, I got really lazy with the negative signs. Remember, with fractions, they're actually supposed to be in between the numerator and denominator. I like to put them wherever I want. And as we see later with graphing linear equations, we're going to see that we actually can interchange that negative sign to either numerator or denominator. But we still haven't answered the question, which is what's the slope and what's the y-intercept? Now that we have it in a form that we recognize, we're able to see that our slope is negative 7/5 and our y-intercept is negative 22 over 5. Again, I can't simplify each of these fractions any further than I have. If I wanted to, I could make that a mixed number, but it's just fine staying an improper fraction. So now that we're able to identify the slope and y-intercept, we're getting a little bit more comfortable than that. We're actually going to start writing linear equations. And the first example we have is writing a linear equation given a slope and y-intercept. So this is going to be our foundation. If we can do this, we can do it all. So on our first example, we can see that we're trying to find an equation of the line in slope-intercept form that has a slope of negative 2.4 and a y-intercept of 0.11. So the most important pieces here are our slope, negative 2.4, and our y-intercept, 0.11. Again, if we remember, our slope-intercept form of an equation is y equals mx plus b. So the only two key pieces of information we need to know are the slope and the y-intercept. And we actually have those. It tells us here that our slope is negative 2.4, and it gives us our y-intercept of 0.11. If we remember from our very beginning, we said that the y-intercept is 0b. This is going to be our y-intercept, that second coordinate, that y coordinate. And so we're given those two. So now here's the easy part. All we're going to do is just write our equation. Y equals, well, instead of m, what's it going to be? Negative 2.4. X plus, and instead of b, what's it going to be? That's right, 11. There we go. That's it. We're done. Pretty easy? Hopefully so. If not, we're going to try another example. So let's look at example 2. It tells us to find an equation of a line that has a slope of 3.5 and a y-intercept of 0 and negative 23. Again, the only two pieces we need to know are the slope and the y-intercept, which is that y-coordinate again. Once I know those two, I can put it in my slope-intercept form. Y equals m x. This time, we have two different ways we can write it. I can either write plus negative 23, or if I want, I can write it with the subtraction sign and have y equals 3.5x minus 23. Either one of those is going to be acceptable when we write our equations in slope-intercept form. Feeling okay so far? Okay, the next two are going to be tricky. So let's look at example 3. On this one, it tells us that we're looking for the equation of the line with a slope of 0, and a y-intercept of 0, 13. Again, we know our slope-intercept equation form is y equals mx plus b. So y equals 0, x plus 13. Okay, this is perfectly acceptable, although a lot of people have trouble having a 0 in for the x. We know that if we actually took the time to multiply those two, we would end up with 0. So a quicker version of this would just be y equals 13. If we have a 0x, it means the x doesn't really even exist. So we're just left with this y-intercept. This is really important right here, because this is going to tell us later on that this is a horizontal line. We don't see this too much until we start graphing, although you might remember it from the slope. All right, our last example is going to be example 4. And on this one, it's asking us to find the equation of a line that has a slope of negative 7.29 and a y-intercept of 0, 0. Again, the two most important pieces of information are the slope and the y-intercept. So again, we have a 0 somewhere else. Uh-oh, tricky. When we look at this, we can see that our slope, negative 7.29, times x plus 0. Much like the previous example on number 3, if I don't have, or if I do have a 0, I don't really need to put anything there. I can get rid of it, and my line is just going to be y equals negative 7.29x. When we graph, this is going to be a whole lot more important to know where that 0 is, or to have it as a placeholder, because it's going to help us to form our line. Okay, so this time we're going to find the equation of a line given a slope and a point. Remember, the two most important pieces of information when we're working with linear equations are slope and y-intercept. So if we look, we're told in our directions that we have a slope of 3. That's super important, but we don't have a y-intercept. So what are we going to do? Well, remember, going back to our very first page that we saw here, we were given our slope-intercept form, which told us that x and y are variables. X and y. We can definitely see them in our equation y equals mx plus b. But do we know where they are within these directions? Hopefully we remember ordered pairs are always written in the form of x, y. Therefore, we know that our x is going to be 4 and our y is going to be 1. Now what I can do is go ahead and substitute those into the variables that I do know in my equation, y, m, and x. So we're going to be looking for b first. So the first thing we're going to do is substitute our variables in. I know y is 1 equals to slope is 3 times x is 4 plus b. So I'm just going to do a little bit of algebra here. 3 times 4 we know is 12 plus b equals to 1. I want to get this b by itself because I eventually do want to know what our y-intercept is. So how do I do that? Again, how do I isolate that? I have to undo this 12 or subtract 12 from both sides. Eek, I'm running into my next problem. So 1 minus 12 is negative 11. Our 12s are gone, equals to b. Again, the two most important pieces of information when we're solving slope-intercept or writing slope-intercept form are the slope, m, and the b. Do we have those two pieces? Yes, we do. We already said our slope was 3, and now we just found our b. Now that I have those two, hopefully we're able to write the equation y equals 3x minus 11. Or again, if you wanted to go ahead and have y equals 3x plus negative 11, that's fine too. Whatever you're comfortable with. All right, so let's look at the next example here. So if we look, it's asking us to find the equation of the line where the slope is 3/4 and it contains the point 2, 4. So again, we notice that we only have a slope of 3/4. I don't have a y-intercept, but I do have a point. So I definitely have an x and a y. So I'm going to substitute those into my slope-intercept form of the equation, y equals mx plus b. 4 is y. M, our slope, is 3/4. And x is 2. Oh my gosh, we have fractions here. We can work with fractions. That's fine. So there's a couple ways we can work with this fraction. One thing I can do is go ahead and put that 1 right underneath the 2. That way I'm multiplying my two fractions. So 3 times 2 is going to be 6. And 4 times 1 is 4 plus b. I can do one of two things. Well, that's a lie. I can do one of three things right now. I can continue working with the 6/4. I can simplify it, or I can make it a decimal. Any of those choices are going to be okay. We can do any of them. I'm going to go ahead and simplify this and make this 4 equals to 3/2 plus b. Okay, now what I'm going to do, is go ahead and subtract, same thing. If I, on the previous problem, subtracted 12 for both sides, I'm now going to subtract 3/2 from both sides. Okay, so I'm subtracting 3/2 from both sides. I know my 3/2 are going to be gone on my right side, so all that's going to be there is going to be b. On the left side, I have 4 minus 3/2. Well, when we subtract fractions, remember, we have to have common denominators. This is having us recall all of our fraction rules. So that fraction actually becomes 4/1. You can't see my denominator. There it is, 4/1. And to make them have common denominators, I know that common denominator would be 2. So I have to multiply my 1 by 2 and my 4 by 2. So that gives me 8/2. 8/2 minus 3/2 is 5/2. And we found our b. Now that I know what b is, and I already have my slope, means I can go ahead and finally write my equation. Y equals my slope, 3/4, x plus my y-intercept, 5/2. Does it matter if it's fractions? No. Earlier we saw those. It's going to be the same exact thing. Okay, now I'm going to have you guys try some on your own. If you need to, go ahead and just, go ahead and rewind if you need another refresher. So if we look, you can't see that, sorry. Okay, so I'm going to give you a couple seconds to try number 1. Pause the video. Hopefully you came up with y equals negative 2/3 x plus 14/3. Again, don't be freaked out by the fractions. They exist. Okay, now I'm going to give you guys a little bit of time to try problem 2 on your own. Pause the video so that you can do this. Hopefully you got y equals 6x minus 26. If you did, great job. And if not, it's totally fine. Just feel free to go back, rewind, and try this all again. If not, you can totally ask me questions in class. All right. So the last way that we're going to be able to find equations or write equations is given 2 points. So this is by far the hardest way that we can write equations when we have no information. Remember, the only 2 pieces of information that we need are slope and y-intercept. If we look here, our question gives us only 2 points. That's it. So what can we do with those 2 points? Well, if we recall at the very beginning, the one thing that we can do with any 2 points is find a slope. And that's actually something that we need. So I'm going to go ahead and find my slope first. And I'm going to label my points. We should be familiar with this as we were working with our slope from the last video. So we have x1, y1 and x2, y2. All I'm going to do is substitute those points into my equation. So y2 we can see is 2 minus y1 is 3. x2 is negative 2 minus x1 is 2. 2 minus 3, negative 1. Negative 1 minus 2 is negative 4. Okay, so what happens right here? Well, remember, a negative divided by a negative will cancel out, and we're just left with our slope, 1/4. Okay, so now that we have that, remember, the 2 pieces of information we need are the slope and the y-intercept. But all I have is the slope and some points. So can I really find an equation? Yeah, we just did. Remember when we were finding equations given a slope and a point? Yay! So that's exactly what we're going to do. Once we find our slope, we know what to do. We can choose whatever point we want to work with. It's going to come out the same way. Just for this example, I'm going to try 2, 3, only because those are going to be positive numbers. So if we look, the next thing I'm going to do is substitute all of the values that I know into my slope-intercept form. So y is 3, m, our slope, is 1/4. We just found that. And x is 2 plus b. So if I go ahead and look at this, I can see that I'm going to need to multiply some fractions. 2 times 1 is 2. 4 times 1 is 4. If we look at this, again, we have 3 things we can do. Work with it, simplify, make it a decimal. Either way, it's going to work out fine. I'm going to go ahead one more time and simplify this. So we have 3 equals 1/2 plus b. Well, how do I get that b by itself? I have to subtract the 1/2. So I'm going to do that from both sides. On the right side, we know we're just going to be left with b. On the left side, we have to remember that this is 3 over 1. And how do I subtract fractions? I have to have that common denominator. So this becomes 6 over 2 because I multiply both the 3 and the 1 by 2. Now that I have 6 over 2, 6 over 2 minus 1 over 2 is going to be 5/2. Okay? Now that I've solved for my y-intercept, I have the 2 pieces of information I need. My slope and my y-intercept. Remember, those are the only 2 pieces of information that I need. So now I can go ahead and put this in my formula. Y equals 1/4 x plus 5/2. Again, don't let the fraction action be freaking you out. Let's try one more example together. So on this one, it's asking us to find an equation of the line containing the points 2, 4, and 3, 5. Again, I can't do much with 2 points, but I can find the slope. So that's exactly where I'm going to start. Let me label my points. Go ahead and put them into my slope formula. So y2 is 5 minus y1 is 4 over x2 is 3 minus x1 is 2. 5 minus 4, 1. 3 minus 2, 1. 1 over 1 is 1. So this is actually a really nice slope that we have here because not only is it a whole number, it's 1. All right, so the next thing I'm going to do, once I have that slope, I'm going to choose either of my points. They're both positive. It doesn't really matter. I kind of want to stick with the first one because these are smaller numbers. 2 and 4 are just a little bit smaller than 3 and 5. But again, it won't matter which point we use. So now I'm going to substitute all the values that I know into my slope-intercept formula. So y is 4. M, our slope, is 1. and our x is 2. 1 times 2 is 2 plus b equals to 4. Now this one's going to be super easy because we know all we have to do is just subtract 2 from both sides. We're going to end up with 2 equals to b. Now that we're done there, I have the 2 key pieces of information that I need, my slope and my y-intercept. So I'm just going to go ahead and throw those into our slope-intercept form. Y equals 1x plus 2. If you wanted to feel adventurous, you could always write it as y equals x plus 2, knowing that that coefficient there is the invisible one. Either way is going to work. All right, now you guys get to try some on your own. So the first one, and again, I apologize, I tried to white out with marker. Didn't help so much. Okay, so you guys need to find the equation of the line that contains the points -1, 2, that's a 2, and -3, -2. So pause the video right now and try it on your own. Did you get y equals 2x plus 4? If you did, yay, congratulations. And if you didn't, it's totally fine. It's something that we can work on in class.